Hello all, welcome to video lecture series on smart system design. Today I will discuss lecture 1. Myself Dr. C.H. Radhan Prasad, Professor, Department of ECE, SR University, Warangal. Uh, the learning outcomes of this lecture 1 is you may be able to achieve after listening this video. You can define smart systems, then describe working of smart systems. And finally, you can identify real-time smart systems daily we are come across in our life. Let us see the definition of the smart system. Smart system incorporates functions of sensing, actuation, and control in order to describe and analyze a situation and make decisions based on the available data in a predictive or adaptive manner, thereby performing smart actions. So let us see this with the help of a simple example. We all know that our human body is the best example for a smart system. So let us see what happens when a mosquito hit on our body. So let us see. Our body is having 5 sensors. With the help of these sensors, we can get the data. This data is received by your brain. Once your brain is received this information, it will be processed and it is analyzed in your brain based on some memory and some intelligence. Your brain will analyze the data and takes smart actions through actuators available in our body. The actuators available in our body are our bone system, nerve system, and whatever the muscles which are responsible for movement of your body is actuators. With the help of these actuators, your body will react based on the situation. So from this I conclude that human body is the one of the best example for a smart system, which includes a body. That means your entire body is the one of the key element, which includes a processing element, which is your brain, and the brain is connected to several organs. So majorly it uses the sensors for capturing the data from the environment, and in our body we are having 5 sensors, which includes eyes, nose, tongue, ears, and skin. With the help of these 5 sensors, you may acquire information from the environment based on the situation. Based on this data, your brain will analyze the information. After analyzing the data, it will take the decision based on the intelligence available in our brain. So from childhood onwards, we learn something. Based on this learning, we will remember some information. Based on this information, we can perform the actions through our actuators. Uh, then coming to uh, automated systems, smart systems. I given a best example for smart system in the form of human body, but nowadays we are seeing several types of artificial systems, smart systems, which includes object recognition system, one of the best example nowadays, and automatic driver sleepy detection systems based on its facial expressions, and laparoscopy surgeries, and artificial pancreas. So normally one of the system which is uh, implanted on human body in order to maintain the insulin level within our body. So that is called as artificial pancreas, and co- cochlear implants, which are normally used for deaf and dumb people, and virtual reality. With the help of this virtual reality, we can feel uh, environment virtually by dumping uh, false data into your sensor systems. So here your eyes are closed, your ears are closed. So with the help of this, you are entering into a new environment that is not physically available. So that is called as a virtual reality. And robotics is one more example for the smart system. And ACs and smart watches. These are some of the examples we are seeing in our real life. Let us see basic key elements of a smart system now, and we will correlate these components with our human body also. Let us see. A smart product or a smart system typically consists of four basic elements. These elements include sensors, processor or a controller, and actuators, and a plant or environment or body. Now we will relate the sensors. Human body is having sensors, 5 sensors we are having, and here processor is related to our brain. The brain is here processor and brain both are doing same thing. It will process the data which are coming through our sensors or sensor system, and take the decisions and given the instructions to actuators. The actuators perform these smart actions based on the instructions from the processor or a brain. And finally, the body. So the body, the entire system is called as a body or plant or environment. So these are the four basic elements of any smart system. Now let us see working of this system with the help of a block diagram. So let us consider a simple example. I'll explain this with the help of a simple example. With the help of AC. So let us consider we are having a room. It is called as a plant now, environment. So where in AC, normally we will provide AC major requirement is it has to maintain the constant temperature within the room, air conditioner. So the air conditioner is normally placed in a houses, within a rooms, in offices. So that is a plant or environment. From this, to capture the temperature information from the room or houses, normally we provide this temperature sensors. So a sensor system is required where we require some temperature sensor. This sensor here, the basic function of sensor is it captures the temperature and it has to convert into electrical signal. It has to convert into electrical signals. Once it is converted into electrical signal, so the most of the signals which we are getting from the environment is analog nature, and similarly the output of the sensor system is also in analog form only. So that is nothing but it is continuously varying with time. But the processor which we are using in our smart system is operates with binary numbers, digits. So they require some information. And one more thing, whatever the data we are getting through the sensors may not be uh, suitable for the processor. So in such situations, we require some signal conditional circuitry, so which may which are either limiters or filters or some amplifiers. So these are some signal conditional circuits. They may process your signals and then given to analog to digital converter. This analog to digital converter convert this analog electrical signal into corresponding digital information, either 0 and 1. Then this information is fed to a processor or a controller. Here the processor, a controller is a pre-programmed one. So where it will collect the data, based on this data, it takes the decision. So that means it is having some pre-intelligence. We written in the form of a software, so that is available in the controller. Based on that algorithm, it will take the decision. And one more thing, in the AC case, this air conditioner case, sometimes the user is also giving some inputs with the help of a remote. So it is also taking the room temperature as well as user inputs. Based on these two values, it will generate some control signals to the actuators. Okay, but the output of the actuator is also a binary number. But the binary numbers directly we cannot fed to our compressor available in the AC. So that means it requires some uh, signal conditioner circuitry and digital to analog converters. But we are having output of the controller is only in the form of zeros and one. But it should be converted into analog form only. After this also we require some drive circuitry. Uh, and the controller is giving only control signals, but it cannot drive the compressor. But the compressor is operate with a different voltage, that is 230 volts in India, 50 hertz frequency. So that means extra drive circuitry is required. With the help of the drive circuitry, we can turn on and turn off the actuator. Here actuator is the uh, here actuator is compressor. Compressor may turn on or turn off based on the user input and the temperature available within the system. So from this I conclude that the system is automatically captures the user input as well as the environmental parameters and takes the decision and controls the environment. So this type of systems are called as a smart systems. In our daily life we are seeing so many smart systems. Coming to each and every component of this smart system, first let us see sensors. So in our daily life, we are seeing so many sensors. Color sensors are available, and heart rate sensors. These are used to monitor the heart rate of humans, and PIR sensors. These are used for motion detection of humans or animals. Uh, Vibration sensors normally used to identify the vibrations. Most probably normally used in cars nowadays to identify the vibration. And joysticks which are used for gaming purpose, touch sensors, and then sound sensors, and then angle displacement sensor. These are some of these sensors available in the market nowadays. So all sensors are basically converting any physical quantity into corresponding electrical signal only. So based on the electrical signal output, they may be classified into either analog sensors or digital sensors. Digital sensors are nothing but the output of the sensor is only either 0 volts or 5 volts. But whereas analog sensor output is which is varying from 0 to 5 volts. So let us see now. The vibration sensor is a analog sensor. That means the output of the sensor is varying in between 0 to 5 volts. But if you consider PIR sensor, so the PIR sensor identifies only the person is available or not. So that means if the person is moving, so then the output of the sensor is 5 volts. If the person is not moving, output of the sensor is equal to 0. That means it is a digital sensor and this is a analog. Coming to actuators. Actuator is an electronic is a component of a machine which is drives the mechanism or a system. Otherwise, actuator is a component of a machine which is responsible for movement of something. Suppose if you consider here, there is a chain is moving based on this shaft rotation. The shaft is having here teeth. So these teeth are engaged with the chain. So when the shaft is moving, so the chain is also moving. Otherwise, the chain is moving, the shaft is moving. So that means both are here, the gear or the chain are considered as a actuators. They both are responsible for the movement of another component. So the actuators are basically classified into two categories. One is electrical actuators, another one is mechanical actuators. So let us see some of the mechanical actuators. So in our daily life, we are seeing the gears. The main function of the gears are they are responsible for increase the speed or decrease the speed. Normally, we will see in our vehicles. And belt drives. The belt drives are normally used for uh, converting rotational motion from one shaft to another shaft. Then train drives, these are also similar, but the driving mechanism is different. There we are using a belt and here we are using a chain. But both the functions are the same. They are transforming rotational motion from one shaft to the another shaft. Suppose if in a bicycle, the pedal system is moving, the back wheel is moving. So that means the rotation motion of this wheel is transferred to whatever the wheel attached at the but wheel of the cycle. And one more system is the bearing. So the bearings are normally supporting systems for rotating members. So normally these are we can observe we can see in fans and vehicles. So but the function of the bearings are they are supporting system for a rotating members. Rotating members are nothing but rotating shafts. So these are the some of the mechanical actuators. They are responsible for movement of another component in a system. So now uh, let us see the electrical actuation systems. We are coming across so many electrical actuation systems. In our daily life, we are seeing switches. These are normal switches, and this is a push button switch. And some of the electrical actuated systems, switches, relays, and solenoids. The relays are normally used to uh, control high power appliances with low power inputs, and similarly, the solenoid valves are used to control the water flow within the pipes. And some of the semiconductor switches are also available in the market. They are diodes, transistors, and diag, all these comes under the uh, semiconductor switches. And some motors, DC motors, stepper motors, all these are come under electrical actuation systems. The motors are normally used for rotate some wheels and some mechanisms. Uh, what if in our any automated system is there? If you want to move any component, compulsory we require a motor. So these are the electrical actuator systems. Coming to my processor or controller. So there are two different types of systems are there. One is microprocessor, another one is microcontroller. Let us see what is microprocessor. A microprocessor is a CPU on a single IC, so which consists of arithmetic logic unit, some registers, and some control unit. All these three blocks are available in a single IC is known as the microprocessor. All these three functions of a computer available in a single IC is called as a microprocessor. Arithmetic logic unit. The function of arithmetic logic unit is which will perform all arithmetic logical operations, which includes addition, subtraction, multiplication, division by using some data. So the data is coming through some registers or from memory. So the registers are used for temporary storage only. They may be 8 bits, 16 bit or 32 bit, 64 bit registers are available in microprocessors. And control unit. The control unit decides what type of operation to be executed by the microprocessor. So all these are integrated in a single IC is known as the microprocessor. And another one is the microcontroller. The microcontroller is nothing but it is entire system. Whatever the smart system you are designed for a specific application available on a single IC is known as microcontroller. So this microcontroller includes CPU. CPU means microprocessor. Along with this microprocessor, some memory, temporary memory, and some permanent memory, and then IO ports. IO means input-output ports. These are responsible for connecting some input-output devices, and some timers or counters. Timers are responsible for generating the delays, and counters are responsible for counting the events, and some serial communication ports or some other devices. All these are integrated on a single IC is called as microcontroller. So from this I conclude that a smart system is nothing but it is having a basically four elements. They are sensors, a processor, and actuator, some plant. So this smart system is normally installed in a plant or a body. So on this, some sensors are available. With the help of that sensors, it will capture the information and send this information is given to my processor. The processor or a controller. The processor or controller is having a pre-programmed um, information or intelligence. With the help of that intelligence and the data, the microprocessor or microcontroller takes the decision. After taking the decision, it will send the control signals to the actuators. With the help of these actuators, which will perform the smart actions. That's why these are called as smart systems. So thank you for watching. Please like, share, and subscribe. Thank you once again.